Our final speaker for today is Santiago Tafeno, and he's going to speak to us about the impact of southern hake egg production on MSY reference points and the implications for management.
Hi, good evening. I am Santiago Cerviño, and as Joan said, I'm going to speak about the impact of southern hake egg production into biological reference points and the implications for management. So here we have a population cycle. We have the recruits that grow and die, became reproductors that lay eggs and eventually produce new recruitments. If this population is under fishing, part of the individuals that going from the recruits to the reproductors, going now to the catch, and then the low amount of reproductions produce lower eggs and produce probably different recruitment. So in some way, the fishing modifies the whole cycle of the population. So for the fishermen, the fishing activity is a way to put the catch in the market. For us, the fishing activity is the way to control the population dynamics. So our main aim is trying to find out fishing levels, F levels, that is our control variable, that produce some kind of answer in the population, that you can measure this answer in terms of reproductors, in terms of eggs, or including in terms of catch or yield. So basically, is what the reference point means. No? You have different reference points that are different levels that represent the state of the desirable state of the population and the desirable state of the exploitation. So you have, first of all, a family that you can call the yield per recruit reference points that basically quantify a value of the yield produced by every recruit that comes into the fishery. You have a second family of reference points that you call the stock per recruit reference points that measures how the fishing mortality changes the depletion of the reproductor, could be total reproductor or female reproductor, or the percentage of reproduction of the eggs. These two family of reference points just consider a part of the whole cycle. The fishing mortality alters the whole cycle, and these reference points does not consider the final part of the cycle, that is the stock recruitment relationship that links eggs with recruits. This is the third family of reference points that is what you call FMSY. In this case, we consider the whole cycle, but we have to take into account the stock recruitment relationship. That is, most of the times, is a big problem. So the three families has pros or cons, and all of them are valuable to manage a stock. So along this stock, I'm going to review the relationship between the reproductive potential measures with these three family of reference points. And to do that, the talk structure, first of all, to estimate the different reproductive potential measures. After that, to fit stock recruitment models, estimate biological reference points, and then try to conclude something. So the first point is to estimate different reproductive potential measures for the southern hake. The data I have is the results from the length-based model from 1 to 130 centimeters from years 82 to 2008. And I've selected the second quarter, that is the season that the peak of the recruitment. The biological information that I have is the growth, the maturity at length, estimated yearly, total and female, the sex ratio at length, also yearly, and the fecundity at length. This is an estimation done just for a couple of years that is applied to the full series. So in these three plots, you have the biological information, the maturity proportions, the sex ratio against length, and the fecundity. So for the maturity proportions, what we can see is that the female mature, wow. that females mature later, at larger sizes than males. If you look at the size ratio, you can see also that the males disappear after 70 centimeters. So until 130, most of the population are females. And if you look at the fecundity, for the fecundity estimation, you only have observations between 40 and 80 centimeters. So we have developed two models for fecundity. One continue exponentially after 80 centimeters, and another one continue constant after 80 centimeters. But what you can see in the range of the values that we estimate is basically that the eggs per unit of weight increases from something like 10 to something like 50, so 5 times more eggs in this range of observations. With these informations, the numbers from the model and the biological informations, we built 4 different reproductive potential measures in the same way that was explained many times here. But what I'd like to emphasize is that basically we are adding a biological complexity to the 4 categories in a sequential way, but we can look at these 4 different indexes in a different way. That you apply the index of the numbers at length, we apply a weight that is basically putting more weight in the largest individuals. The females mature later than the males. The sex ratio is for the females at the larger sizes, and the egg production is also bigger for the larger sizes. And you have 2 different models for egg production, for egg fecundity. One constant after 80 centimeters, and another that continues exponentially. So we have 4 different variables of reproductive potential that are SSB, female SSB, egg production constant, and egg production exponential. All of them, there is a gradual increment of the larger fish that having impact in the population reproductive potential. So the SSB, the larger fish has less weight than in female SSB, that in egg production constant, than in egg production exponential. So if you look at the trends, here you have the trends for the recruitment, the SSB, female SSB, and the egg production. The first thing that I like to emphasize is the good recruitments in these recent years compared with the historic trends. If you look at the reproductive potential measures, you look at good values at the beginning of the time series, not at the end, for all of them. And if you look at the recent years, the only one that somewhere could reproduce the increasing in recruitment is the SSB. The egg production have not increased in this year, so obviously this means that this implement of biological realism doesn't explain these good recruitments. If you look at the same information in other way, just looking at the correlations, we can look that most of the reproductive potential figures has the same similar, a higher linear correlation, and this is more similar between consecutive steps in the weight of the larger fish. And if you look at the linear correlation with the recruitment, basically we can see that it's something near 0. So basically, looking at the trends of the 4 reproductive potential, we have similar trends for all of them. And at first glance, more biological realism does not help to explain the recent good recruitments. So the next step is fitting the stock recruitment models with the 4 reproductive measures and with 2 recruitment models, 2 classics, Ricker and Beverton-Holt, and with a Bayesian fit with non-informative priors. So here you have the 8 fits for the SSB, the female SSB, the egg production constant, and the egg production exponentials. What we can see here comparing Ricker with Beverton-Holt is the big differences at larger stock sizes, basically caused by some points that derives the Ricker, the overcompensatory side of the Ricker curves down and the Beverton-Holt up, and also difference at low stock levels in the slope at the origin. If you look at the quality of the feed, what we can see, basically, looking at the Vegans information criterion, is just the best model in terms of dig. It should be the recurve with SSB or female SSB. So the incorporation of more biological realism doesn't help to improve the quality of the model. However, changing this perception has impact on the recruitment, and what we're interested in is to compare the different reproductive measures, the 4 reproductive measures among them. This is not possible looking at the slope, but you can look at the steepness. That is, steepness is defined as the fraction of the recruitment from an unfished level, unfished population, obtaining when the stock is at 20% of its unfished level. So in practical terms, higher steepness means higher productivity. So when we compare the steepness at the 4 with the 4 reproductive potential, we can look at trend related with the value of the larger individuals on the population. This trend happens in both with Ricker, with an increase in steepness, and with Beaverton Hall, also with an increase in steepness. So my explanation for that is when we modify the stock terms in the stock recruitment relationship, basically the depletion of the low abundance population is higher when we consider that the larger individuals have more value in the population. And as the recruitment is also high at these low values, as we saw in the plots, this has impact on the steepness of this relationship. So in this case, the introduction of the change of the biological information, the introduction of more biological, drives to an increase on steepness, partially caused by this high unexpected recruitments in recent years, when the population was a really low level. So, as concluding for the stock recruitment relationship, there are big differences between Ricker and Beaverton Hall regarding the slope at the origin, regarding the overcompensation. And regarding the reproductive potential, there is not improving in the recruitment prediction when we incorporate more realistic biological information, but it has impact on the steepness, changing the productivity perception of the stock. So the third part of the analysis is to estimate biological reference points in the 3 families that I mentioned before. So for the first one, that is the yield per recruit, this has not implication on reproductive potential. However, it's a proxy for FMSY, and it's a usual practical information to compare with the others, since it doesn't change when we change the biological information on reproductive potential. The next family of stock or biological reference point, the stock per recruit. What I did to compare one with each other is to scale all of them to 1. So when the fishing mortality is 0, all of them has 1. This allows us to compare for the common use values, like could be 30% of spawning per stock per recruit. So when we look at the 4 different reproductive potential measures, you can follow also a trend when you relate them with the value of the bigger fish in the population. So to get the 30% of SSB, female SSB, egg production constant or egg production exponential, to get the 30%, you can get it for the SSB with a 23, with an F of 23, that decreases to 21, to 19, to 16. So to get the same reduction, the same depletion of the stock, if you look at different measures, you have to apply a different fishing mortality. That is lower if the value of the larger fish is more important. So this has sense because the fishing activity, the first thing that reduces is the larger fishes. So if you want to preserve it on the fishery, it seems like logic to reduce the fishing mortality. Okay, let's jump that. Let's go to MSY. Considering the whole cycle now, so including the stock recruitment relationship, that for the different, for SSB, female SSB, egg production constant or egg production exponential. This is the Ricker FMSY that you can see a trend also that increases from SSB to egg production. It's well over Fmax. If you look at Beaverton Hall, that is the upper limit is Fmax, you can look at the same trend. But if you remember the previous slide, we look at the proportion of spawning per recruit, and look, you have an opposite trend. What is the explanation for this opposite trend? In this case, we are just considering the stock per recruit. When you consider the whole cycle, you get an opposite trend. In this case, the explanation was the depletion per recruit, but if you remember, you have also an increase in steepness. So you produce less spawning per recruit, but this stock produce more recruits. So in the balance between them is winning the steepness, I should say. Probably this is driven by the high recruitments in recent years. So, well, this is more or less explain it and go to the conclusions. More biological realism was introduced. Bigger hake are more productive. This is no doubt about that. This evidence is on that. So, however, there is not strong changes in the historic trends. Regarding the stock recruitment relationship, there is not improving on the feed, but there is changes on the perception of the productivity related with the steepness. What is the impact on the biological reference points? There is a trend in a proportion of stock per recruit that is related with the depletion per recruit. There is an opposite trend in FMSY, and these apparent contradictions can be explained in terms of compensation between steepness and stock per recruit fraction. But I have, it's not an answer to that, but it's more a question that I thinking is regarding, is it valid that assumption that the same proportion of stock per recruit as an FMAX process under different reproductive potential measures? I mean, when we consider different population dynamics, different life histories, the proportion that you need to apply to get a good process for FMSY could change. Here, we are not changing the life history of this stock, but we are changing the way what you look at this stock. So this is an open question that I have no answer yet for it. Thank you very much. So, in some way, the fishing modifies the whole cycle of the population. So, for the fishermen, the fishing activity is a way to put the catch in the market. For us, the fishing activity is the way to control the population dynamics. So, our main aim is to produce new recruitments. If this population is under fishing, part of the individuals that going from the recruits to reproductors, going now to the catch, and then the low amount of reproductions produce lower eggs and produce probably different recruitment.
Our final speaker for today is Santiago Tafeno, and he's going to speak to us about the impact of southern hake egg production on MSY reference points and the implications for management.
Hi, good evening. I am Santiago Cerviño, and as John said, I'm going to speak about the impact of southern hake egg production into biological reference points and the implications for management. So here we have a population cycle. We have the recruits that grow and dies, became reproductors, that lay eggs, and eventually is trying to find out fishing levels, F levels, that is our control variable, that produce some kind of answer in the population, that you can measure this answer in terms of reproductors, in terms of eggs, or including in terms of catch or yield. So basically, it's what the